So in the second video on dividing radicals, we're going to look at something called rationalizing the denominator. And really what that means is it means removing the radical from the denominator. Mathematicians are kind of an anal retentive lot, and they do not consider a fraction to be in simplest form when you have a radical in the denominator. So we need to talk about how we're going to remove the radical from the denominator. Now we did a little bit about in the first part of the video, but these questions are a little different. You're going to notice in the first example that this is a coefficient and that's a radicand, so I cannot divide those things. So what you do to rationalize the denominator is you multiply the numerator and the denominator by that radical denominator that you have. So you get 1 times root 13, which is root 13, and root 13 times root 13. When you multiply a radical by itself, it's just the radicand. In the second case, this looks like some of the questions we saw in the first video, but we cannot divide 5 by 2. So what we have to do is we have to multiply the numerator and denominator by this radical in the denominator to rationalize it. So root 5 times root 2 is going to give us root 10, and root 2 times root 2 is just 2. Now you cannot divide 2 into 10 because this is a radicand and this is a coefficient. You cannot divide those things. Coefficients divide into coefficients and radicands into radicands. Next example, you could divide root 2 into root 6, but you would end up with a fraction, and they really don't like those things. So what we're going to do is we're going to multiply the numerator and the denominator just by root 6. So root 2 times root 6 is root 12. Root 6 times negative root 6 is going to be negative 6, because a positive times a negative is a negative, and root 6 times root 6 is just 6. Now you can simplify the square root of 12. It's the square root of 4 times the square root of 3 over negative 6. Well, this gives us the square root of 4 is 2, the square root of 3 stays, and we have negative 6. Now we can still simplify this some more. 2 divides into negative 6. 2 divides into itself once, it divides into negative 6 3 times. So you end up with root 3 over negative 3 because you end up with a 1 in the numerator and a negative 3 in the denominator. In the last case, we're going to multiply by root 3 over root 3. Well, root 3 times root 3 just gives us 3 in the denominator. Root 20 times root 3 gives us root 60 in the numerator. Now, you can simplify 60. 60 is the square root of 4 times the square root of 15. The square root of 4 is 2 root 15 over 3. So there's your answer in simplest form. In the next example, we're going to look at a couple of different ways they've written things. You're going to notice that you have a coefficient and a radicand in this example here. You only have to multiply the numerator and denominator by the radicand. You do not have to multiply the 3. So 7 times root 7. Remember, that 7 gets multiplied by this coefficient of 1, which we have on our radical. So 7 times 1 is 7, root 7. Here, root 7 times root 7 is 7, and 7 times 3 gives us 21. So going through that again, root 7 times root 7 is 7, and you have to take that 7 and times it by 3 to give you 21. Now you think you're done, but you have to realize the 7 and the 21, they're coefficients, so they can divide into each other. 7 divides into itself once, it divides into 21 3 times. Now we're finished. When you get a single radical like this, you can break it up into 2 radicals. That's root 18 over root 5. Now, we cannot divide 18 and 5, so we multiply the numerator by root 5 and the denominator by root 5 to come up with our solution here. 18 times 5 is 90. 5 times 5 is 5. Root 90 is the square root of 9 times the square root of 10 over 5. Now the square root of 9 is 3, root 10 over 5. And again, you cannot divide 5 into 10 because 1 is a coefficient and 1 is a radicand. In this case, you can do the same thing. You can multiply by root 72 and do that, but you can also simplify this before you multiply out. This is 3 times the square root of 4 times the square root of 3. 72 is, let's see, 9 times 8. It's 36 times 2. So when we simplify this, square root of 4 is 2. 2 times 3 is 6. So we get 6 root 3. Square root of 36 is 6. So you get 6 root 2. Well, the 6's cancel out. And now all you have to do is multiply the numerator and denominator by root 2. And 3 times 2 gives you root 6. Root 2 times root 2 is 2. Another way you will see root 6 over root 2 written is you will see it written as 1/2 root 6. Last example, we're going to rationalize this denominator. We're going to first of all simplify what's in the numerator. So we get 3 times the square root of 9 times the square root of 2 minus the square root of 4 times the square root of 3 all over the square root of 2. Square root of 9 is 3. 3 times 3 is 9. This gives us 9 root 2 minus square root of 4 is 2, and we have a root 3. Now, there's a couple ways to do this. You could break it into 2 parts. It's going to cause us a little more writing. So what I'm going to do is just rationalize the denominator by multiplying this whole binomial numerator by root 2. That means you have to multiply each of these terms by root 2. So you get root 2 times root 2, which is 2, and 2 times 9 is 18. Root 2 times root 3 is root 6, and you still have a coefficient of 2. And root 2 over root 2 is just 2. Now, what you're going to notice is that 2 divides into 18 and 2 divides into 2. So if we divide 18 by 2, that gives us 9. And if we take negative 2 divided by 2, that just leaves us with negative root 6. So if you can divide this denominator into the 2 coefficients, you go ahead and do that. And there is the second part of dividing radicals.